Hello, people, and welcome back to another session. In this session, we'll be looking at one-way analysis of covariance or ANCOVA. In our previous session, we touched upon one-way analysis of variance, ANOVA, where we discussed the procedure of figuring out whether the groups which are present in our population set, whether those groups are different or similar to one another. Now here, in case of ANCOVA, what we are going to be studying is we are going to be studying the impact of other variables which are not considered while making our ANOVA model, but they still might have a significant impact on our analysis. Now, these variables are called covariates. They are usually numeric and continuous in nature. Now, the nature of these variables is that they do not play a significant role and they are usually marginalized when it comes to studying the impact of the difference in groups. However, in certain cases, they have impact on how the groups are distinct from one another. So, inherently, what we are trying to prove over here, or what we are trying to postulate, is whether the measuring factor, which may be the mean, maybe the systolic blood pressure in an example, whatever the situation, whether the groups are different through that measuring factor in and of themselves, or does it have an external impact of some other variable, or to paraphrase it, does the difference among groups is caused by an additional impact of a covariate, and they are not independently separate in and of themselves. That is something that we are trying to showcase using one-way ANCOVA, or one-way analysis of covariance. So fundamentally, the basic concept of one-way ANCOVA is that ANCOVA is a combination of ANOVA and regression. So let us suppose that let us suppose I have a response variable y, which is basically dependent on this is what we studied when we studied our application of one-way analysis of variance using regression. This is the equation which we precisely studied. Your your dependent variable y was a function of your independent groups, or basically what you can say, your relation of or comparison of each group with the reference group. So out of all the reference group, one of the groups is taken as the reference group, and we are basically doing comparisons with respect to that particular reference group. So what we try to prove there, or what we try to postulate there, whether there exist differences between a group and the reference group, and that difference is measured by this coefficient or beta. Now for one-way analysis of covariance, so this right here, this was ANOVA, or one-way analysis of variance. Now for ANCOVA, we are going to study the impact of covariates or numerical continuous variables on my initial ANOVA analysis. As mentioned, it is a combination of regression and ANOVA. So up till this point, group I, this will be same. Yes, this starts from 2, but there will be an additional factor which will be added. It will basically nothing but your covariates. So your xk, this represents your numeric continuous variables or covariates. Right? This is your equation for one-way analysis of covariance. So this is the general idea that we follow when we are doing the test for one-way analysis of covariance, or as they say, ANCOVA. Couple of pointers that you need to remember for one-way ANCOVA is that when you are hypothesizing or when you're postulating the null and alternate hypotheses, you need to postulate that for the entire set. Basically, you are trying to hypothesize or you're trying to find out the evidence for your numeric continuous variable, which are your covariates, as well as for the distinction of groups. So here, your null hypothesis will be beta 1, beta 2, all the way to now my last coefficient will be beta k plus j. All of them are equal to 0. And my alternate hypothesis will be at least 1 beta I is not equal to 0. Okay. So this is the fundamental concept of your hypothesis testing in one-way ANCOVA, where we do the hypothesis testing both for my groups as well as for my covariates. And therefore, while initializing my null hypothesis, I'll take the entire set and I'll check for all the parameters. And for alternative hypothesis, I need to also see whether the groups are different as well as whether my numerical continuous variables or covariate has a significant impact on my model, on my ANOVA model. So in case of ANCOVA, the adjusted means which are calculated, they are called the least square means. Basically, these means are calculated after you adjust for your covariates or your numerical variables. So let us go ahead and let us look at an example of how to do a one-way ANCOVA analysis using R. So if you guys remember, this was the data set that we had, where we had 4 different groups of smokers, and our measuring factor of distinction was systolic blood pressure. Now, what we did initially when we did one-way ANOVA was that we took this systolic blood pressure as our measure, and we took the group as our factor. Now, along with the group factor for ANCOVA, what we need to do, we need to also take into account the covariate. Here, age, the column age acts as a covariate. So we are going to test whether age has a significant impact on the distinction of groups. Are the groups different in and of themselves, or does age have an impact on their distinction? This is the basic idea of one-way analysis of covariance. So with that, also some background on the R function that we will use. So for one-way ANCOVA, the R function that we use is ANOVA with a capital A. This is the R function we use for one-way ANCOVA. So there is AOV, there is ANOVA, and there is ANCOVA. So this ANOVA function is used for ANOVA table. This AOV is used for one-way analysis of variance or ANOVA, and this capital ANOVA is used for ANCOVA, right? So now let us go to R. To start off with one-way analysis of covariance, you need this package called CAR. So if you do not have this package, what you can do is that you can go to tools, you can click on install.packages, and in this you can just write CAR, and here you can click and you can install. Since I already have it installed, I'll directly run this. It might give you warnings, but that's fine. Now here we can create our model called the adjusted model, and this is going to take us, is this will basically have our systolic blood pressure, which is our measure, the group, which takes into account the different groups that we have, and my covariate. So here, in case of ANCOVA, what we have to do is, let me open my notepad. We have to create a model using my measure. It will be an addition of my group and my covariate. This is the basic equation for my one-way analysis of covariance. Let's go back to R. Okay, so data must be part of data frame. Let us check. Let me rewrite it in the. So this is how we created the model. If you look at the summary of this, you will be getting the t values and the p values of all the different categories. And if you can see, you're also getting the p value of age. So as you can see, this covariate is heavily significant. Now, as discussed already, if your covariate is significant on the model, therefore, you can say that this covariate has a significant impact on the distinction of the groups, and the groups may not be different in and of themselves. Okay. Now here we use the ANOVA with capital A to create the ANCOVA model. And if you look at your summary of the ANCOVA model, it basically gives you your summary, but more or less, if you look at ANCOVA.model, this is what it gives you for ANCOVA. As you can see, group and age, it shows again that age is heavily significant while group is not in and of significant of themselves. So you can clearly surmise from here that age as a covariate has a significant impact on the distinction of groups. It's a hidden variable, not considered an independent variable in the model, but still has significant impact. Now to calculate the least square means, we have something called as EM means package. You can again install this using install.packages. You have to give the contrast values. So once you pass model, your model to the EM means function, it will basically give you your EM mean value, your standard error, and your confidence interval for each of the groups. You can also give your contour value for pairwise comparison. With pairwise comparison, it basically again gives you the p-value of each of these comparisons. Now, as you can see, all the p-values are extremely high, and therefore, here we can clearly come to the conclusion that because they are extremely high, these groups are not different in and of themselves. It means that taken independently, they will not be different in and of themselves, but taken with a covariate like age, their distinction surfaces. You can also give the Bonferroni adjustment as an adjust parameter, but if you can see here, Tukey method for comparing a family of four estimates, by default, this adjust value is Tukey, but you can also take Bonferroni. So let us summarize the concept of ANCOVA. First of all, why do we do ANCOVA? We do one-way analysis of covariance because we want to measure the impact of covariates or variables which are not taken as an independent variable in our one-way analysis of variance, but we suspect that they might have an impact. After we take that into consideration, we built a model which is a combination of ANOVA and regression. ANOVA for my groups, regression for my covariates because my covariates are numeric continuous. After I do that, I'm going to check my p-value or my resulting test statistic, or I do hypothesis testing for both my group and my covariate. If, as you can see in this example, my covariate becomes significant, but my groups are not significant, it means my covariate has a significant impact on the distinction of these groups. Next, we saw how to calculate the adjusted means for one-way analysis of covariance or ANCOVA, and how to take into account the insertion of covariate or the introduction of covariate while calculating the least square means. So this was all that we had for ANCOVA. I will see all of you all in the next session with a new topic. Thank you.